DNA is subject to constant damage from environmental exposures and cellular activities. Single-strand breaks are the most common type of DNA lesion. Poly-ADP ribose polymerases, or PARPs, aid in the repair of these breaks. PARP inhibition interferes with DNA repair, leading to accumulation of single-strand breaks and PARP trapping on damaged DNA. During DNA replication, persistent single-strand breaks can subsequently be converted to double-strand breaks, which can only be completely repaired through the homologous recombination pathway without introducing any errors. Many mutations or changes commonly found in ovarian cancers cause deficient homologous recombination repair. BRCA mutations is one of them. In these tumor cells, the inhibition of PARP leads to the persistence of double-strand breaks and accumulation of genomic rearrangements. When cancer cells detect this accumulation of damaged DNA, they initiate cell death. There are a number of factors that determine the efficacy of a PARP inhibitor. Preclinical studies show that the anti-tumor activity of these inhibitors depends on tumor exposure and subsequent PARP-1/2 inhibition. Sustained greater than 90% PARP-1/2 inhibition may be important in order to inhibit DNA damage repair and induce cell death. Furthermore, tumor cells carrying a BRCA mutation are significantly more sensitive to PARP inhibitors than tumors that do not carry a BRCA mutation. A hypothesis is that a PARP inhibitor may need to achieve significantly higher tumor exposure for an anti-tumor effect in cells that do not have a BRCA mutation. To achieve the required tumor exposure, a PARP inhibitor could have a number of pharmacological properties. It should make it into the bloodstream and be around long enough to have a durable effect. Get into the target tissue, the tumor cell, and stay there to selectively inhibit PARP activity. Zejula has all of these properties. In preclinical studies, it has shown to be a selective PARP-1 and 2 inhibitor that concentrates in the tissue relative to plasma, delivers greater than 90% durable PARP inhibition, and a persistent anti-tumor effect.